Assalamualaikum. Today we will present about our project for reinforced concrete design BFC34803 for section 2. Our group members are Muhammad AIZAT bin Ahmad AZMY, Melvern KEAT HENG, AZAREA BATRISYIA binti Muhammad HAMDEN, EVIRIA FREDERICK dan HEMA SWILNA HENDRICK. Reinforced concrete, also known as reinforced cement concrete or RCC, is a composite material in which reinforcement with better tensile strength or ductility is added to make up for the relatively low tensile strength and ductility of concrete. The reinforcement is typically embedded with steel reinforcing bars, but not always, before it hardens silently in the concrete. Typically, reinforcement plans are created to withstand tensile tension in specific concrete areas that could result in undesirable cracking or structural collapse. The objective of this project is to comprehend and put what was learned into practice. The proposed building will be built in any place in Genting Highland to research and design the structural system and idealization, ideas and assumptions, plan and layout, analysis and design and details. And the last one is to have an exposure on building design procedures according to EVIRIA code. The design consideration for this project is the building has lift or staircase at any area in any building. All variables and permanent action must follow recommendation. And wind action must be considered in all dominant direction. Number of floor is minimum of 4 story. Maximum height of floor is 4 meter. Foundation to ground floor has height of 1.5 meter. The building must be designed in two separate purposes: parking area, commercial area, office, hotel, shopping mall, and others. The foundation must be designed according to the soil condition at location chosen. Any relevant assumption can be applied wherever necessary.
Hi, my name is Melvern KEAT HENG with matrix number F190103 and I'll present architectural drawing. This is the architectural drawing for ground floor, first floor, second floor, third floor, and roof. Next, I'll continue with structural drawing. This is the structural drawing for ground floor, first floor, and second floor, third floor, roof, and another roof. And that is all for drawing. Thank you. Next, we have simply supported one-way slab. The effective length is 6,250 mm with slab thickness of 200 mm and the nominal cover is 25 mm. The effective depth is 165 mm. As required is 172.03 mm square per meter. As minimum 231 mm square per meter. As max 8,000 mm square per meter. For main bar, we use H10 350, which gives us 224 mm square per meter, and secondary bar H10 300, which gives us 262 mm square per meter. And this is the detailing. That is all for me. Thank you.
Hi, my name is AZAREA BATRISYIA binti Muhammad HAMDEN. We'll be talking about the simply supported two-way slab. For the characteristic action is the permanent GK is 2.02 kN per meter square and the variable for GK is 2.5 kN per meter square. The design life is 50 years and the fire resistance is R60. The materials for the characteristic strength of concrete is 25 Newton per millimeter square and the characteristic strength of steel is 500 Newton per millimeter square. The unit weight of reinforced concrete is 25 kilonewton per meter cube. For the main reinforcement, the effective depth is dx 170 mm and dy is 160 mm. For the short span, the RK is 0.167 and the S is 456.07 mm square per meter. For the long span, the K is 0.167 and S is 484.57 mm square per meter. Their minimum S is 238 mm square per meter and their maximum is 8,000 mm square per meter. This is the detailing for the calculation, and their slab thickness is 200 mm and the concrete cover is 25 mm. And that is all from me. Thank you.
Hi, have a good day, doctor, and good morning. My name is EVIRIA FREDERICK. Matric number is AF190024. So today I'm going to present the design that I have done which is slab design. This is the continuous one-way slab supported on beams on 6 sides, with the length 6,350 millimeters and the width 3,000 millimeters.
The next one is the continuous two-way slab. On this slide is already been stated the specification for the continuous two-way slab, and there is the figure for the continuous two-way slab that's been on the calculation. While on this slide, I will be showing you the bending moment for the continuous two-way slab for the short span and the long span one. And the next part is the shear force for the continuous two-way slab, and I will be showing you for the short span and the long span. They have a different value for each calculation.
A very good day to Doctor. My name is HEMA HENDRICK, and now I'm going to explain about my part in slab calculation. So for this part, I choose two-way restraint slab. The slab section is 123/C to D. So the cross-sectional area of reinforcement that used after calculation is first, for secondary bar we use H10 325. Next H10 300, and the third one is H10 225. Next H10 300, and the last one is H10 225. So as we can see here, this is the detailing of the slab after the calculation. And that's all from me. Thank you.
Hello and Assalamualaikum. My name is Muhammad AIZAT bin AZMY and my matric number is AF190206, and today I would like to present about the brace frame. What is brace frame? A brace frame is a strong structural system commonly used in structures subject to lateral loads such as wind and seismic pressure. The members in a brace frame are generally made of structured steel which can work effectively both in tension and compression. The beams and columns that form the frame carry vertical loads, and the bracing system carries the lateral loads. For the frame specification, design life 50 years, fire resistant R60, exposure classes XC1, characteristic strength of concrete 25 N per millimeter square, characteristic strength of steel 500 N per millimeter square, and unit weight of reinforced concrete 25 kilonewton per millimeter cube. The characteristic action permanent GK, concrete, surface plus finishes, mortar 0.03 times with 19 and we get 0.57, suspended ceiling 0.15, surfaces 0.30, toilet style 1.0, finishes 2.02 kilonewton per meter square, and variable QK 4 kilonewton per millimeter square because of the shopping area. This is our shear force diagram, kilonewton, and bending moment diagram, kilonewton meter on brace frame. That's all for me about brace frame, and thank you.
Next, I'll present for unbraced frame. For unbraced frame, we have 3 calculations, but for this video presentation, we'll take wind load as an example. First, we'll get the average of roof height, which is 17.5 meter, and then the width times the length, which is 25 meter times 25 meter, and the effective depth is 165 millimeter, and VSIT is 30.82 meter per second, and the desired velocity wind is 35.44 meter per second, and lastly the dynamic response factor CDYN is 0.836, and this is the distribution of the wind load.
Assalamualaikum. My name is AZAREA binti Muhammad HAMDEN with metric number AF190148. We'll be talking about the critical column in the calculation. As you can see on this slide, this is the critical column, whole building, the figure for the whole building, but I will be showing you the first floor. The GK is 2.02 kilonewton meters cube, QK 4.0 kilonewton per meter cube, FCK 25 newton per millimeter square, and FYK is 500 newton per millimeter square. As you can see, the maximum ultimate loaded at each floor is the 54.54 kilonewton per meter, while the minimum ultimate load at each floor is 7 kilonewton per meter. For the column lot, the first floor is the 141.75 kilonewton, while 2 until 4th floor is the 777.2 kilonewton. For the column support for the first floor is 14 kilonewton, and the column support for 2 until 4th floor is the 56 kilonewton. So the total of the column lot is the 988.95 kilonewton. As you can see on this slide, this is the table for the calculation of the critical column for every floor.
Hello and Assalamualaikum. My name is Muhammad AIZAT bin AZMY and my metric number is AF190206. And today I would like to present about the biaxial axis column 1 over G. So for specification, loading, roof finishes 1.2 kN per meter cube, roof variable 4 kN per meter cube, floor finishes 2.02 kN per meter cube, floor, ground and first variable is 4 kN per meter cube, floor second variable 2.5 kN per meter cube, design of concrete 25 kN per meter cube, and the dimension, roof slab thickness is 200 mm, floor slab thickness 200 mm, main beam 200 mm times width 500 mm, secondary beam 200 mm times width 500 mm, and the column is 200 mm. So for the LY, secondary beam 6.25 meter, and the LY main beam 6.25 meter. This is our reinforcement that we get from our calculation. For reinforcement, we use 2H16 as our group bars. Diameter link is 8 mm, S-max, HX 300 mm, and we use HX 225 for our spacing bars. So this is our detailing for column 1 over G. That's all for me about column 1 over G, and thank you.
Next, I'm going to explain about the column calculation for my part. So I choose column middle. So for the column section is 2 to 4 slash C to 3. And the cross-sectional area of reinforcement that used after calculation is first 6H20, next 4H25, H6 250, and the last one is H6 150. And that's all from me. Thank you.
This is the corner column, concentrically loaded column, and type of column is slender column, thread column.
Assalamualaikum, my name is AZAREA BATRISYIA binti Muhammad HAMDEN with metric number AF190148, and I will be talking about the combined footing. As you can see on the slide, there is a figure for a combined footing. Combined footings are constructed for 2 or more columns when they are close to each other and their foundations overlap. The first one is the footing size. The surface load is the NA and NB. The sum of NA and NB is the 1169 kilonewton. While calculating for the area of footing, it is the sum of the service load plus self-weight will be divided by soil bearing capacity, and the answer will be the 8.6 meters square. And for the reinforcement, you can see that the effective depth for dx and dy is 504 millimeters, while dy is 492 millimeters. For the longitudinal reinforcement, for the bottom is the drk is 0.167, while the ES is 1356 millimeters square. And for the longitudinal reinforcement top is drk is 0.167, and their AS is the 1286 millimeters square. For their reinforcement, you can see that the transverse reinforcement for the bottom one, and this is the data for the key and the AS, while for the minimum and max is, for the minimum is 688.8 millimeters square per meter, and their maximum is 22,000 millimeters square per meter.
This is my foundation design. So this is pile cap truss theory. Pile diameter is 100 mm. Design load is 1204.52 kilonewton. Cover to reinforcement 75 mm. Grade of concrete is 30. Characteristic strength of steel is 500 Newton per millimeter square. Size of the column on the pile cap is 400 times 400 millimeter. Thank you, that's all from my part.
Hello, my name is AZMY and my metric number is AF190206, and today I would like to present about the footing 1/G. So for the specification, ultimate action axial 733.78 kN, moment 19.25 kN, and the materials concrete SCK 25 Newton per millimeter square, the reinforcement equal to 500 Newton per millimeter square, and the cover 75 mm, and diameter bar is 16 mm, column size 500 mm times width 400 mm, and for the pile cast RC pile 300 mm times width 300 mm, and the working load 600 kN. So this is our reinforcement that we get from the calculation. Effective depth dx equal to 517 mm, dy 501 mm, longitudinal bar k equal to 0.167, as provided is 478.07 mm square over m, and as mean 403 mm square over m, as max 14,400 mm square over m, and we use 12H16 2,412 mm square for our group bars. So this is our detailing for footing 1/G, and we use 4H12 as our binders, and for the length is 1,500, and for the height is 600. That's all for me about the footing 1/G, and thank you.
Next is design for pad footing, axial load only. The column size is 400 mm times 400 mm. The seat nominal is 35 mm. Footing size is 4.5 times 4.5 times 0.7 meter. And the AS required is 4,706 mm square. And the AS minimum is 4,076.1 mm square. And the AS max is 126,000. For main bar, we will use 42H12, which gives us 4,746 mm square. And this is the detailing for pad footing, axial load only.
Next, I would like to explain my part in foundation calculation. So, my part is the pad footing with axial load plus moment. So, the column size of the section is 400 times 400 millimeter, and the cross-sectional area of reinforcement that used after the calculation is first at H25, which is 3,929 millimeter square, and the last one is 4H32, which is 3,218 millimeter square. So as we can see here, this is the detailing of the pad footing after all calculation. And that's all from me. Thank you. Now I'm going to explain about the discussion of this project. So, the design in this report comprises design of slabs, staircase, frame analysis of the building, wind load analysis, design of columns, and design of foundations. So, the types of slabs that we use in this report is first, one-way simply supported slab, two-way simply supported slab, one-way continuous slab, two-way continuous slab, and the last one is two-way restraint slab. And for foundation, we use pad footing using beam theory, combined footing foundation, pile cap using truss theory, pad footing with axial load and moment, and the last one is pad footing with axial load. Next, as we can see here, this is the picture of result of wind load by using esteem software at different angle, which is 0 degree, 90 degree, and 180 degree. And continue, this is the result of wind load by using esteem software at 270 degree. So as we can see the table at our right side, this is the wind load result by using the manual calculation. So by using all these results, we can compare the value from the manual calculation and by using the esteem software. And that's all from me. Thank you.